So we're finishing up our chapter 10 by looking at complex numbers. So what are complex numbers? Well, up here, let's read this through. So usually when we see the square root of negative 16, we say that it's an undefined or that it doesn't exist because we talked about this back in 10.1. What number multiplied by itself is going to give me negative 16? The only possibilities would be negative 4 or positive 4. And when I multiply each of those by themselves, they give me positive 16. So there isn't a real answer. However, in some situations, we do need to evaluate these radicals. So what we have is, to be able to find the square root of negative 16, we use a whole different number system. We use the complex number system. Okay? So you've been taught up till now that the real numbers are all of the numbers, and that is true in the fact that the real numbers are all numbers that can be represented on a number line, which is how we usually graph numbers. So any number that we have known up till now, including things like pi and the square root of 10, those could be graphed on a number line. Imaginary or complex numbers cannot be graphed on a number line. So they have this whole new set of numbers. Here's a definition. When we talk about something called the imaginary unit, we write that as I. And by definition, I is the square root of negative 1. The square root of negative 1. So you can see that definition right here. The square root of negative 1 we have defined as I, the imaginary unit. Which means, by the way, that I squared is going to be negative 1. So these are two things that you're going to want to know. So how does that help us? Well, look, if I have the square root of negative 25, now again, up till now, we have not been able to find an answer for that. What we're going to do is we're going to split that up into the square root of 25 times the square root of negative 1. Perfectly legal, what I just did. Well, what's the square root of 25? That's 5. And we have defined the square root of negative 1. That is that imaginary unit, and we have defined it as I. So the square root of negative 25 is actually 5i. And whenever you see that I, it means we're talking about imaginary numbers, which are a part of the complex number system. I can do the same type of thing here. I can split this up into the square root of negative 1 times the square root of 3. This is not a perfect square, but I know that the square root of negative 1 is I, and root 3 is as simplified as it gets. When you have a radical, you're going to want to make sure you put the I in front of that radical, which is why I did that. Let's work on C. Well, first of all, let's work on this part right here. So we know that the square root of negative 50 would be the square root of negative 25 times the square root of 2. Hopefully we can all agree with that, because negative 25 times 2 is negative 50. And then don't forget about this negative sign in there, so we're going to pop that out there. Well, we can split up the square root of negative 25 as the square root of negative 1 times the square root of 25. So let's see, what's the square root of 25? We know that's 5. And the square root of negative 1 we know is I. So all three of these together give me negative 5i. The negative comes from here, the I comes from here, and the 5 comes from here. And that is what we get when we simplify. So whenever you see the square root, and this is only for the square root, because the definition is that I is the square root of a negative number. Cube root, any other root doesn't work. It's only square root. So whenever now you find that you are looking at the square root of a negative number, you can use your complex numbers, your imaginary unit, to be able to actually simplify it. All right, so now let's multiply these. Now here, when you are talking about negatives underneath the radical, you cannot just multiply them and get the square root of 21. That does not work when you're talking about the complex number system. You have to simplify them first. So you know that the square root of negative 3 is really the square root of negative 1 times the square root of 3. Right? So that's going to be I root 3. And you know the square root of negative 7 is really the square root of negative 1 times the square root of 7, which is going to give me I root 7. So you must simplify those. Now, hopefully you're kind of getting a little bit of a trick here. Whenever you have the square root of a negative number, the negative can just simply come out of the radical as an I. Because what you're really doing is you're taking the square root of negative 1 out, and it becomes an I in front. So see, this is I root 3, and this is I root 7. So that's a little bit of a shortcut here. So now we can multiply these together, though. So I times I is I squared, and root 3 times root 7 is root 21. Now, let's go back up into our definition. Remember, what is I squared? By definition, I squared is negative 1. So see this I squared here? I can just call that a negative 1. And there I have my answer. Now look at this. Now this happens to be a perfect square. So what's the square root of negative 25? It is 5i. And what's the square root of negative 1? Well, that's by definition simply 1i. So if I multiply those together, I get 5i squared. But don't forget, I squared is negative 1, which means my answer is negative 5. So now we have this kind of cool set of all new numbers that we haven't dealt with before. They're called the set of complex numbers. We are going to have to learn how to add, subtract, multiply, and divide them. But it's kind of fun. As math goes, I think complex numbers are kind of cool. So a complex number is a number that can be written in the form a plus bi, where a and b are real numbers. So here are some examples. 3i is a complex number. And that is true because I can write it in this form, a plus bi. It's just that my a happens to be a 0. That's okay. 3 plus 2i. That's a complex number. My a is 3 and my b is 2. 3 minus 2i is a complex number. My a is 3 and my b is negative 2. Negative 8i is a complex number because, again, I can write that as 0 minus 8i. So my a is 0 and my b is negative 8. Guess what? All numbers we've been dealing with so far, all real numbers, are also part of the complex number system. 16 is a complex number because I can write that as 16 plus 0i, where my a is 16 and my b is 0. So every number that you know of so far, every real number, is also part of the complex number system. So now we know what they look like. Now we're going to figure out how to add them. So if you look, here are the rules for adding and subtracting. Basically, if I'm adding two complex numbers, I add the real parts. I add the a and c, and then I add the parts with the I. So do you see where it's really combining like terms? You can think of it as combining like terms. And same thing with subtraction. So let's go ahead and let's do an addition problem. So again, if I'm going to add these two numbers, I'm going to add these real parts. So 8 plus negative 4 is 4. And then I can simply add negative 5i plus 1i to give me negative 4i. And that is all you have to do. Even though I isn't a variable, it has a lot of the same qualities that a variable does. In other words, you can use it in like terms. Look at this subtraction problem. Well, does it make sense to you that we can just distribute through the negative? So 9i minus 1 plus 6i. And now I'm going to combine like terms. I'm going to get negative 1 plus 15i. That's all you have to do. Now, when you write your answers, they're going to want it in the standard form, which is a plus bi. So make sure that your real number without the I comes first, and your number with the imaginary unit comes last. So in other words, don't write this as 15i minus 1. Have the negative 1 first. So we've added, so we subtracted. Let's multiply. How do I multiply two complex numbers? Well, if you look at them, do you see where you're just going to FOIL? So here we go. We're going to get 8. Outside, we're going to get negative 2i. Inside, we get negative 12i. And at the end, now be careful here, negative times a negative is plus 3i squared. That's going to be our tricky part. So if we combine like terms, we're going to get 8 minus 14i plus, now remember, this is going to be 3 times, what's I squared? I squared is actually negative 1, which is going to be 8 minus 14i minus 3. 3 times negative 1. So now I can just combine these to get 5 minus 14i. And there's your solution. So FOIL, but always making sure that you remember that I squared is negative 1. Does this look like a distribution problem? It is. So if I distribute that negative 3i through, I'm going to get negative 6i. And then going here, I'm going to get negative 3i squared. But remember, I squared is really negative 1. So a negative 3 times a negative 1 is going to be plus 3. And then don't forget, you want to write it in a plus bi form. So you're going to have 3 minus 6i. How do you square a complex number? Well, no surprise, you're going to write it out twice in FOIL. So if I do that, I'm going to get 25. Outside, I'm going to get negative 5i. Inside, I'm going to get negative 5i. And at the end, a negative times a negative is positive I squared. So that's going to be 25 minus 10i plus, but wait a minute, I squared is negative 1. So that's going to give me 24 minus 10i. So there's multiplying. Our last thing we're going to do is we're going to divide them. Now, remember how when we talked about radicals, you couldn't leave an I in the basement? Or I'm sorry, a radical in the basement? Well, because I is actually the square root of negative 1, you can never leave an I in the denominator of a fraction. So we're going to talk about the conjugate again, just like we did with radicals. The conjugate of a plus bi is a minus bi. You just simply change the middle sign. And just a quick note, don't forget that if you multiply two binomials, in this case they happen to be complex numbers, you just have to FLA. So what happens when you do this is you get negative b squared I squared But remembering that I squared is -1, you get negative b squared times -1. That's why that is a plus b squared. So let's go ahead and let's do this. So we can't have an I in the basement. So here's a division of two complex numbers. So we're going to multiply top and bottom by the conjugate of the denominator. So we would have to FOIL the top. So 2 times 3, that's going to give me 6 minus 2i minus 3i. And at the end, we're going to get positive I squared, and we're going to deal with that in a minute. On the bottom, if you FLA, you're just going to get 3 times 3, which is 9. And at the end, you're going to get negative I squared. All right. Well, if we just keep going, this is going to be 6 minus 5i minus 1, because don't forget I squared is a negative 1. And on the bottom, you're going to get 9 minus, again, negative 1, because I squared is negative 1. So that's going to give me 5 minus 5i all over 10. And then the very last thing you can do is you can divide a 5 out of all 3 of these parts. As long as it goes into all 3 of them, you can divide it out. So that's going to give me 1 minus 1i all over 2. And there's your final answer for that division problem. Do we have one more page? Yeah, we have one more page. Okay, let's talk about our powers of I. Now, this is the definition. We've already seen that. We already know that I squared is negative 1. Now look, I cubed is negative square root of negative 1, which is negative I. Because if you look, I cubed, isn't that really I times I squared? And since we know I squared is negative 1, that's I times negative 1, which is negative I. So I cubed is negative I. I to the 4th, isn't that really I squared times I squared? Well, I squared is negative 1 times negative 1. I to the 4th is 1. Knowing these 4 things, you're going to be able to figure out what I to any power is. Now, before we go into our first example down there, I want to do something a little bit smaller right up here. What if I had, for example, I to the 7th power? Would you agree that I could write that as I times I times I times I times I times I times I? That's 7 I's. If I circle these 4, what have I just circled? Well, what is I to the 4th power? It is 1. Every time you circle 4 I's, they just disappear, because then it becomes 1 times. So that's 1 times I cubed. And what did we just say I cubed was? It is negative I. So I to the 7th is negative I. If I had I to the 6th power, think of it. It's I times I times I times I times I times I. If I circle 4 of them, they disappear, because that's really 1. So I to the 6th is the same thing as I squared. But what do we know I squared is? I squared is negative 1. So here's the deal. I'm not going to write out 32 I's. Here's the shortcut. Divide 4 into whatever the exponent is. Now, think of it. I divide 4 because every time I have 4 I's, they just disappear, because I to the 4th is 1. So 4 goes into 32 8 times with a remainder of 0. So what that means is that if I had 32 I's written out here and circled my groups of 4, they would all be in a group of 4. So it would really be 1 times 1 times 1 times 1 times 1, which is simply going to be 1. I to the 32nd power is 1. Let's do I to the 43rd. If I divide 4 into the exponent of 43, 4 goes into there 10 times with 3 left over. It's the leftover that you want to be careful of, because the leftover is how many I's there are left when you circle your groups of 4. So I to the 43rd is the same thing as I to the 3rd, because there are 3 left over, which we know is negative I. So look at the leftover. Because the leftover was 0 here, that's why it's 1. I to the 62nd. Let's divide 4 into 62. Well, 4 goes into 6 once. 4 goes into 22, 5. The key is that there are 2 I's left over. So I to the 62nd is the same thing as I squared, which we know is negative 1. Let's do the last one. Let's divide 4 into 121. Well, 4 goes into 12 3 times. 4 goes into 1 0 times. And the key is that there's a remainder of 1. So I to the 121st is the same thing as I to the 1st, which is simply I. So put it all together. What does that tell you? Look at the remainder. If the remainder is 0, your answer is 1. If the remainder is 3, your answer is negative I. If the remainder is 2, your answer is negative 1, because that's I squared. And if there's 1 remainder, think about it, that means that everything is in a group of 4 except for 1 lonely I at the end, and the answer is I.